Hello student, in this video lecture we are going to study the probability distribution of two geometric random variables and example. Okay, first we obtain the probability distribution of two geometric random variables. Okay, first we see the statement. Statement is suppose x1 and x2 are independent and identically distributed, independent and identically distributed random variables having geometric distribution with parameter p, then x1 plus x2 does not follows geometric distribution. Okay, this is the statement. Means we have two random variables. These two random variables are independent and also identical. Means both variables have same distribution with parameter p. Okay, now we have to prove this one, or we have to obtain the probability distribution of x1 plus x2. Okay, now proof of this statement is since x1 follows geometric distribution with parameter p, then its probability mass function is given by, then its PMF is given by, okay, probability mass function. Probability of x1 equal to r, which is equal to p into q raised to r. Here r takes values 0, 1, 2, dash dash dash, 0 otherwise. Okay, and x2 follows geometric distribution with parameter p, then its PMF is given by, probability of x2 equal to r, which is equal to p into q raised to r. Here r takes values 0, 1, 2, so on, 0 otherwise. Okay, now let z equal to x1 plus x2 equal to small n. Now we have to obtain the probability mass function of z, which is equal to x1 plus x2, which is equal to n. Now we obtain the probability mass function of random variable z, that is probability of z equal to small n, which is equal to probability of x1 plus x2 equal to n. Okay, now this can be written as, which is equal to probability of x1 equal to 0, x2 equal to n, plus probability of x1 equal to 1, x2 equal to n minus 1, again plus probability of x1 equal to 2, x2 equal to n minus 2, plus so on, plus probability of x1 equal to r and x2 equal to n minus r. Now this can be written as probability of z equal to small n, which is equal to summation of probability of x1 equal to r comma x2 equal to n minus r, summation over r running from 0 to n, again which is equal to summation of probability of x1 equal to r into probability of x2 equal to n minus r, summation over r running from 0 to n, since x1 and x2 are independent. Okay, so x1 and x2 are independent. In that case we can write the joint probability is equal to this product of the probability of x1 equal to r into probability of x2 equal to n minus r. Then we know that the probability distribution of random variable x1 and random variable x2. Now we write the probability distribution of random variable x1 and x2 here. Okay, now which is equal to summation over r running from 0 to n. Okay, then probability mass function of random variable x1 is p into q raised to r into probability mass function of random variable x2 is p into q raised to n minus r. Both x1 and x2 follows geometric distribution with parameter p. Now this q raised to r and minus q raised to r gets cancelled. Okay, and we have only summation of p square into q raised to n, summation over r running from 0 to n. Now p square into q raised to n, this is the constant term. Okay, this is the constant term, therefore which is equal to p square into q raised to n into summation of 1 summation over r running from 0 to n. Okay, probability of z equal to small n, which is equal to p square into q raised to n into summation of 1 summation over r takes values from 0 to n. Then the value of this summation is equal to this n plus 1 into p square into q raised to n. Okay, this is the probability mass function of random variable z, n plus 1 into p square into q raised to n. N plus 1 is the value of this summation of 1 summation over r running from 0 to n, which is equal to n plus 1. Okay, now we see one example on this geometric distribution. If the probability that a certain test yields a positive reaction, if the probability that a certain test yields a positive reaction is equal to 0.4, is equal to 0.4. Then what is the probability that less than 5 negative reactions occur, less than 5 negative reactions occur before first positive one. Before the first positive one. Now solution of this problem is, what is problem? If the probability that a certain test yields a positive reaction is equal to 0.4, what is the probability that the less than 5 negative reactions occur before the first positive one? Now by using geometric distribution we can find the required probability. Now first we define the random variable x, then p is the probability of success, and then we write the distribution of the random variable x, and finally we find the required probability. Now let x be the number of negative reactions before the first positive one. Okay, this is the random variable x, means what? Number of failures before getting the first success. This is the geometric random variable. Then p is equal to probability of a certain test. P is equal to probability of a certain test yields a positive reaction. Okay, this is the p, and p is given. P is equal to 0.4. okay, this implies that q is equal to 1 minus p, which is equal to 1 minus 0.4 is equal to 0.6. P is equal to 0.4. P is called as the probability of success and Q is the probability of failures. Means here P is the probability of positive reaction and Q is the probability of negative reaction. Okay, then we are given the total number of trials. Now here X follows geometric distribution with parameter P. Then here random variable X follows geometric distribution with parameter P. Then its probability mass function is given by probability of X equal to small x, which is equal to P into Q raised to X. X takes value 0, 1, 2, so on, 0, otherwise. Okay, this is the probability mass function of geometric distribution with parameter P. P is equal to 0.4. Now we find the required probability. Probability of, what is required probability? Find the probability that less than 5 negative reaction occur before the first positive one. That is, this X is less than 5, which is equal to probability of X is less than or equal to 4. Now again, which is equal to probability of X equal to 0 plus probability of X equal to 1 plus probability of X equal to 2 plus probability of X equal to 3 plus probability of X equal to 4. Okay, now put X equal to 0 in the above probability mass function. Then we have only P. Q raised to 0 is equal to 1. Then put X equal to 1, then probability is P into Q. Put X equal to 2, probability is P into Q square. Then put X equal to 3, then probability is P into Q raised to 3. And lastly, put X equal to 4 in the above probability mass function. The probability is P into Q raised to 4. Okay, now take P common from each term. Okay, which is equal to P is taken common, then write down the remaining term in the bracket. First term is 1 plus Q square plus Q raised to 3 plus Q raised to 4. Okay, now the bracketed sum is the sum of the first 5 terms. Okay, sum of the first 4 terms with geometric progression, and here is common ratio is 1, first term is 1 and common ratio is Q. Therefore P into the sum is 1 minus Q raised to, this is Q raised to 4 upon 1 minus Q. This Q gets cancelled. This is the sum of geometric progression, that is, here is 1 minus Q raised to 5 upon 1 minus Q, which is equal to P into 1 minus Q bracket 1 minus Q raised to 5 upon, this is P. PP gets cancelled. We have only 1 minus Q raised to 5, and which is equal to 1 minus 0.6 raised to 5. This is the probability of X less than 5, which is equal to, the required probability is 0.9224. This is the required probability, that is, the less than 5 negative reactions occur before the first positive one. Okay, thank you.